Yay!
Okay, so welcome everyone. This is Geek Week. This is our programming workshop, and we hope to eventually be able to get you guys to program something on Melman over there, who's currently just a drive base. I don't know if we can show virtual people, but
Yeah.
I'll just bring it over for a second.
Oh yeah.
So this is Melman. This is
Technology.
one of our 2023 robot after we took its arm off. Can you see it, by the way, on your side?
I can see it.
Okay.
Why it's nodding.
So yeah, that's basically the robot that we'll be using for Geek Week. And my name is Cedric. And then the other person leading this is Eden. She is not on camera.
Walk this way, Eden. Walk towards me.
Okay.
There you go.
We should.
Yep.
What do you do?
What do I? Oh, right. That's important. So I'm the core programming lead of 525. Basically, I do most of the stuff that directly involves the robot. For example, all the subsystems and all the motor control and everything. If you don't understand any of that terminology, don't worry. We'll get to that at a later date. And Ian, what do you do?
I am in charge of things off the robot, so auxiliary stuff. So a lot of like simulation, dashboard stuff, autonomous AI, vision, that kind of thing. And we'll also go over that later on.
So to just quickly review the syllabus, we have contact information on here. We'll be going over some of the software that we'll be using just throughout the season. For example, like GitHub and like the WPI library and VS Code. And then we will be eventually splitting into two main work groups, being core and auxiliary. And core will be working on basically making some drive-based code for Melman, as well as using gyro information and LED subsystems. And then what will auxiliary be doing?
Auxiliary is going to work a lot on some dashboard stuff, so that's kind of some stuff that we display to the robot to do matches and stuff and allows us to display values. We'll also be working on some simulation stuff along with AdvantageK and AdvantageScope, which we'll go over. And additionally, when the 2 weeks are over, we'll be consolidating both the core and auxiliary work groups on the last day to combine the drive-based code and the auxiliary code to create a full robot.
Yeah, more or less as full as we can make for Melman over there.
Yeah.
So first of all, let's go back to the slideshow. Oh wow. Ooh. I'm not gonna. Okay. So day one setup. Today we're just gonna go over installation of our software, as well as joining, for example, for our team members, the GitHub repo. And
I'm sorry. I think that the presentation froze on.
It did freeze. It did freeze.
There we go. There you go.
Wait. Okay. Let's just let it play out.
Now.
Oh, that's the other thing. Okay.
I'm so sorry.
We're so sorry, guys. Okay, but we'll be going over GitHub stuff as well as all of the documentation, and if we have time, we'll go over some basic programming terminology for those who haven't programmed before. So, first of all, we're going to install. Yep.
First of all, does everyone have a computer? Raise your hand if you do not. Okay. Actually, raise your hand if you have a Chromebook. Okay.
That's fine. Chromebooks should be fine. You just won't be doing a lot of the stuff that we'll be doing today. For example, like installing stuff, because you can't install many things on Chromebooks. So we will begin with basically installing VS Code, which is the way that we code. It's basically the platform we use to do all of our coding. So if you go to this website, so basically just search up, I believe. Yeah. Okay, I can drop this. Yeah.
Can you actually put it in the chat as well for the Google Meet?
Yep.
Do you have the slides? Can I get a link for the slides?
Yes.
As well?
Right now?
Yeah.
Okay.
Make sure that they are shared appropriately.
Okay. Okay.
There's the link for the slides.
Yep. We're just going to go until maybe day 2 today.
Yep.
And then, so go to, I'll drop this in Slack too. Can we do that?
I can do that.
Okay.
I can get it into Slack Max as well. I'll put it in general.
You got it.
For our sport dogs, that's in the sport dog Slack.
So you'll basically just be going to this page and then downloading the WPI library, which depending on your operating system will either be Windows, Mac, or whatever you have.
And you just push that button, and it takes a while to load. So we'll just be going
Are you fine
around.
with me downloading this again on your computer? No.
So
But how will I know what button to hit if he doesn't hit the download button, Colin?
He's hovering right over it. The
Ah,
only difference is he's not going to click, and you should.
Yeah.
you're such a problem solver.
okay, so we'll give that some time. So
Yep.
Do you need help? Just raise your hand.
Mine says 3 hours left.
That's why we're doing it first.
Okay.
Yeah. That's probably.
Because it does take a while. Oh, the internet speed isn't an issue with your room; it's an issue with your computer.
No, it's not my computer. It has jumped up to 7
4
hours.
hours. Oops.
Are you not going back?
I think I was like
4 hours left.
Yeah.
I got
6,
140 in the
7,
I think
9,
we're-
12, 18, 1 day.
Okay, it's gone back down to 5.
I got up to 9 days. Can you beat that?
9 days? Oh my god. There's the reason we're doing this first. I'm down to 1 hour.
Back down to 2 hours.
Okay, did everyone, super quick here, did everyone that is currently downloading the WPN library, did you all find the link and are downloading it? Okay.
Thumbs up. Ooh. Wyatt, Drew, do you guys need any help?
I'm all good.
Thank you, Wyatt.
Drew, if you have
Drew,
any
if you
trouble, you
need
can just
help, let
chat.
us know. If you need us to repeat anything, let us know.
I'm good. I've done this before. I'm good. Thank you.
Okay.
Drew's ahead of the curve.
Yep.
Sweet.
He's set.
Drew doesn't need to take 9 days to download it, unlike Josh.
Just a question for you guys.
Yep.
Are you guys able to install this on your school laptops or no?
No, not ours, but we have found an extension on VS Code that allows us to still use those laptops to program. And
Interesting.
We'll be using that in future days.
Okay. Yeah. Very interesting. Cool.
As long as everyone's good, I think you have to
Okay.
Yeah.
Then he goes, everything right.
I have the ISO downloaded from
Did you get it?
Good job.
Awesome.
You holding the laptop?
This is a different laptop.
It's on the student Wi-Fi. Can you browse the network for shares? Or the PCs?
Oh, so you're saying like it's just sent over? The biggest thing about Link is it also downloads everything else, like VS Code and everything. So it downloads the whole package as a whole.
I get you.
And it's really, it's very intuitive for people who haven't done a lot of software stuff in the past.
Okay.
So it's very expensive too. And it's the mainstream way that people do it. I feel like it should be fine if we do that, but I don't have experience doing that.
Yeah, I mean, I know you can scroll down. Installers. Listed right here. But you know, So Intel or ARM, it sounds like these guys know better which one you should.
Okay. So everything So,
8 minutes.
okay.
Yep.
Everyone listen up. Yeah, Cedric's gonna show you if you're on this. It should look
Yep.
something like this. If you cannot find something like this, just let us know and we'll help you out.
Yeah. So as Ian said, it'll pop up like this, and then you basically just follow along. You click start, and then you'll click everything, and generally you'll click install only for this user, and then we recommend that you
Before we go into much further, we should make sure that everyone has it downloaded.
Because mine just finished downloading.
ooh. Hey, that's a quick 4 hours, 5
Yeah.
hours.
That was a quick 9 days.
That's Josh. I don't know if he's done it. He's done it.
Yeah.
Okay, Josh, how close is your download?
Are you getting it, Mr. Patrick?
How many
I
days
am
left?
getting it. Thank you.
Don't worry about it. You're good.
I'm
No,
opening
no,
up
no,
the
no, no,
installer.
Don't worry about it. I was walking towards
He can't.
and the last year was as I was driving. Don't worry. That's okay.
You download the stuff if we're not.
Now he's still on. I'll just do it at home.
Okay.
I don't
Yeah.
No, for.
Oh my gosh, I need to change mine.
That looks painful.
How are you guys doing?
Why are you bragging about that?
Yes.
I was just joking. You're good to go, right? Okay. So you do download the computer only fastest, and then
Zach, pull up a chair.
Chairs are the.
We're out of chairs up here.
47 seconds remaining.
Cedric, I think you can probably go through those steps for our friends.
Yep.
Mine.
So yeah, if you have it downloaded, like I said before, you just open up the downloader, and then you click start, and then everything install for this user. Just tell us when you're ready. Good. Okay, and then download for this computer only, and that will take a while.
And then you hit next, I assume, when you're done with that. And it
Yep.
does that loading screen.
Yes, it should. Yes.
Extracting.
Oh, oops.
okay, so
Yep.
So Zach, if you go to the Slack, there's a link on there, and you're gonna. Oh, you're on Chromebook, so you won't be downloading it anyway. Never mind. I was trying to be helpful. To be fair. Oh gosh. Oh, it's happening.
What's happening?
Look at that command prompt.
Command prompt.
Oh, it's downloading.
Command prompt.
Have I ever had VS Code installed? No.
Really?
Sorry for being late.
VS Code has a built-in command prompt.
It's basically just a fancy command prompt.
It's not that fancy. It's literally just a command prompt.
Well, like it looks fancy. In my opinion.
And everything that VS Code command prompt will do, your command prompt will do as well.
Yeah.
Do you know what my favorite IDE is?
what is it?
It's Idle.
I know
It's
that.
a lie.
I disagree. I disagree.
It's not Idle. You know what Idle doesn't have?
Disagree
Line
about
numbers.
That depends on the version of it.
That's fair. The version of Idle that I have installed doesn't have line numbers.
Are we supposed to put this?
Yes.
So what else is that? What else is that?
Remember that
GP.
this meeting is recorded and going to be posted on our YouTube channel, just as a reminder to all of our students in the room.
Thank you. Like and subscribe.
Thank
So,
you,
yeah.
Zach.
If you're not on Mac or Linux, that will be probably it once you have everything downloaded, just click finish.
Just thinking about it.
Thinking about finishing?
Who's this?
Just decline it. Yeah, we got the school.
We do not have school on Friday.
I'll be there.
We don't.
Hello.
And we won't be able to.
What I usually do is whenever you don't have a school day like that,
Are you going to?
I constantly convince myself that we do, so that I'm surprised and happy when we don't.
Okay, then we do have school on Friday evening.
Oh.
You do have school on Friday?
I have school on Friday.
Anyway, are we good to go?
Okay,
Okay.
Okay, are you good? Okay, if you go back to your homepage.
Wait, what did you do?
Okay, did you finish?
Yes.
Okay, go back to your homepage after that. There should be something.
Eden, can you help those two individually, and Cedric, can you
Where?
keep going?
So,
Okay.
go down.
So after this, we will be adding people to our GitHub that are on our team. For those who are online,
So, super quick thing I want to say about GitHub. So GitHub is this thing that we use to do this thing called version control. Cedric, do you want to explain what version control is super quick?
sure. So version control is basically a way that we organize our work. What you're able to do is you're able to take a version of something, and then you're able to branch off of a certain version. So generally it's called main, which is the root of all of our code. And you can branch off to certain other projects, and basically you're able to add on to it. And in the end, you're able to merge it back in with your original code. So it basically allows us to work on a ton of different things at the same time. And we can always basically maintain main as something that always works.
Yep. So the idea being that when you're starting work on some new thing that you're adding to the code, you start with that version of main, whatever the latest version is. You create a branch, is what it's called. You do all your work in that branch, and then once you know that your stuff works, then you can merge that back into main. And so at the same time, two different people can be working on two completely different things, and know that their stuff isn't going to be affecting each other until they both know that their stuff is ready to go.
Yeah. And then they can both implement it into the main and everything breaks.
Ideally, no.
Hopefully not.
Ideally, we implement one thing before, and then we check that works before we implement that one thing, and then we implement that one thing into the other thing. So basically, merge main back into our other branch, make sure that works, and then we merge everything back into.
So you're not making simultaneous new branches. It's you've got something that works. You change it over here. You put it back.
Well, we make simultaneous branches, but we don't generally merge a ton of things at the same time. So Colin might draw a diagram.
All right. This is probably going to be kind of hard to see. Cedric, when I'm done with this drawing, can you show?
Yes, I will show the. I'll show the virtual.
Okay, so we've got one version, and then say we've got another version,
Yes, I do.
and then someone wants to start working on something new, so they branch off over into something, a new branch. They're doing their work, and at the same time, someone else wants to do their new task, right? So they are making their own commits. Let's say this second person, they finish up their work. They say, okay, I tested everything. It's good to go. I want to merge that back into main. So this is our new main right here. In order to merge this branch in, the first thing that we have to do is take all the stuff in main and bring it into this branch, make sure that everything works together, and then we can bring all of it back into main.
All right.
So that's how you have two different things. That's how you implement two different features.
Yeah.
We're able to see the diagram here. So we start with this version of main. We come up to this version that's just work people have done. Two people start working on something at the same time. One of them finishes, and that gets merged into main. The other person has to take the new stuff that the other person was working on, merge it into their stuff, make sure everything works, and then all of that combined work can go back into main.
The glare is like just perfect to block out some of that.
Oh, perfect.
It's okay. I think I saw some nods, so we're gonna go with that. People understood what was happening.
And of course, the more people you have working on the more things, the more complicated that graph gets.
Which can get very, very complicated at times. But the goal is to make it all organized. So if everyone's done with VS Code installation, we will move to getting people onto GitHub. For the teams that aren't here, you might have something different. You might have something like GitLab or some other version control, but we generally use GitHub. And unfortunately, you won't be able to join our team's GitHub. Are you gonna? Probably not.
So our team's GitHub is where we keep code that we want that we're not ready to release out to the public yet. So
yeah.
So we can show the process just so that everyone's familiar with how to actually, make a GitHub account, get set up with being added to an organization and things like that. But for those that are on the call that are not Sport Dogs, we'll unfortunately not be adding them to our org.
Okay. So everyone here, go to just search up GitHub, and you can probably click the first link that pops up, and that will give you bring you to GitHub. And then if you don't have an account, create one. And if you do have an account, just sign in, and we can get you onto our team's GitHub.
And people who have Chromebooks can do this stuff as well.
Yes, you can do this with your Chromebook.
Brian, grab a chair. There we go.
I can just send you an invite by using your email.
All of our teams.
So let's do
LCD and Thanks, man.
no problem. Oh, Colin. Authentication code.
Authentication code. Oh no. I have it.
Yeah. You're also like back in the admin.
I see what you've done.
Yeah, I'm trusting you. Don't mess with our GitHub. I'm trusting you to not do anything you shouldn't.
I think if I do anything, it'll be very visible to everyone. Yeah, lots of it.
Okay. Any students that get invited go in
This is
Oh, sweet. All right. We will get you added to mentors.
If you have complaints about what I do, you can get me in way more trouble than
All right. You should have that invite.
yeah. Basically, once you have your GitHub account, basically just tell us it, and we can invite you to our team.
Mine is J. Kirkpatrick 525.
I think you're already in.
My old account's in there, but I set up two-factor authentication and then promptly forgot
Your
what the
password.
second factor was and can't get logged in. So J. Kirkpatrick 525, that's me.
I'm assuming I can add Kirkpatrick as a mentor.
Yes.
I'm gonna destroy it all.
In fact, I'm surprised you weren't already.
Oh,
Well, I was, and then I set up two-factor authentication on my GitHub account, and then I promptly forgot what the second factor was. Like I used some sort of app to do it, and I don't remember what app I used. And so I got locked out of the account.
That's fine. I'm pretty sure I have like 4 or 5 accounts.
Yeah. Perfect.
Yeah, right?
Okay, perfect. Units all Cedric. Account is made.
Do you have the WPN library on the computer?
I believe I have 2023 version. Okay, as long as I don't have to open up my super secure Google Sheet worth of passwords.
You should have an invite.
All right.
Do you get the other
No,
one?
we're higher than that. That'll be 539 yet, but
What's Wyatt doing? Is Wyatt doing stuff? Not really.
As long as it's like,
Snooping would be
Yeah.
We're not checking.
Okay, so we're
No, they're distributed.
I'm sorry.
Yes, this Jake Kirkpatrick map is me.
I'm trying to remember how to.
What are you looking for?
I'm too lazy.
Yes. I use this for college.
That's you, right?
I wrote a 469.
Gabe, if you want to send it, go to your organization.
okay, raise your hand if you have an account and you're not yet.
I'm wondering what that was.
So,
You guys, raise your hand if you have a GitHub account and you're not yet in the Sport Dog organization. Okay. Do you want to tell us your username?
it's both an L, a lowercase L instead of the one.
Okay.
Are you unique now? Are you unique? Did you just copy mine? Gave you a unique. That's right.
All right. Siggy, can you repeat that so Cedric can get you added?
It's
Gabe's, but with a lowercase.
is it that?
Instead of a one.
Is that it?
Yeah. What the heck? Gabe, who's unique now?
That's gonna be slightly confusing. Okay.
Yeah, Siggy, good job.
So
That's
just-
gonna be very confusing.
Just get your organization and just have it.
No.
Zachary, right?
So it's
Do you have a GitHub account?
Organization.
Tyler, are you ready?
You have your Jamie alternate?
okay.
We asked for everyone who's not in the organization to raise their hand.
Welcome to Gabe.
What's my Discord? Sure is.
Skip first one. There we go. I think I've made it. Why is everything? Oh, there's all of the everything.
Okay, so whenever
Should I put
Cedric's
in my
you can
name
go
again?
and then I'll send you an invite.
Okay, Tyler, what's your name?
Like this? Right, it's something I wouldn't be disappointed in myself with.
Very nice.
I'll do this in chat one day.
Sure. Oh well, we also have the
Oh,
Documentation.
right, something that's very
just a place to find documentation.
Okay.
We can just like quickly talk about it. We don't have to like go over it in detail.
You can look in
You can go over that.
Canvas,
You can
but
go
I
over
don't
that.
think they're obligated to.
I got
yeah.
my GitHub set up.
What's the error? Tell me the error.
Capital with a capital Z. Zach Zero Coder, no spaces.
This?
Yes.
Okay. And then Parker, are you in?
Okay, should something have happened?
We'll go to your organizations.
Where?
And then should be
Where?
Oh, I love organizations name.
Okay. Focus talks, everyone. Listen up. Raise your hand if you are not in our organization. You're not in our organization.
I can't find the organization.
Okay, so if you go to the top right.
Okay.
Is everyone else in?
Is everyone else in? Okay, perfect. So the next thing we're gonna go over is documentation. Raise your hand if you're in a computer science class right now.
I'm in 5 of them.
Oh my god.
You lead 5 of them.
Not 5 of them, but I'm in.
I wish I could have a
Okay.
schedule like that.
So basically, what happens if you don't know what to do? Oh, you're okay. Never mind. What happens if you don't know what to do and you need to find a specific like method or something like that? What do you look for? What do you look on? I guess. Zach,
The documentation.
you're so right. Okay, so for Java and for FRC, we also have something like that. So it's something called the WPI lib API docs. So this is something we use a lot in programming. we essentially, you can go here, you can look up for any method you want. It's similar. You can like look through specific things like classes and everything, but right here is really essential. You can find it by going to the WPI Lib 2024 FRC docs in general, and you can go to the side over here and go look for the right over here. Yes, Colin.
I hear you keep saying WPI Lib.
Mhm.
What is that?
So WPI Lib is kind of the organization we run code through, and it's like WPI Lib. I don't know what it stands for exactly.
So WPI is a school. It's the
Yeah.
Worcester Polytechnic Institute.
that
Yes.
one.
And then WIPI Lib, like it is a library and stuff, right? Library.
Yeah. So the lib in WPI
Yeah.
stands for library. The whole idea is that we've got a lot of hardware on a robot that we need to control it, right? Writing the code to tell a robot how to behave is definitely doable within one build season. But if we also had to write the code that specifically told a motor how to actuate, hey, I need you to apply this much voltage for this amount of time in this sort of phase. If none of that made sense, that's okay. It doesn't have to, because the WPI Lib takes care of that for us.
Mhm.
The whole idea is that the WPI Lib offers some classes that we can use to represent things like I've got this kind of motor on my robot, or I've got this kind of sensor, and we can interface with the WPI library, and the WPI library will handle all of the interaction with the real hardware on the robot.
Yeah, exactly. And so the difference between VS Code and WPI Lib is basically VS Code is a thing we actually program on. So it's like what you all downloaded, whereas the WPI Lib is a library where you can access different code rather than where you program it. Does that make sense to everyone? Anyone have any questions? Okay, so that kind of marks the end of our kind of like our download section of this presentation. And now we're kind of going to go on to basics, unless there's anything that Cedric would like to add to our previous.
Not really.
Okay, perfect. Okay, so now we're just going to move on to some basic programming concepts. Most of you will be familiar with some of these concepts, so we just want to review it to make sure that you guys know what it is. So you guys know what it is.
I just don't see what's going on.
Oh, okay. Yeah. And it'll get harder, obviously. I'm sure you all know, but just stick with it for now and we'll get through it. You want me to start? You want to start? Okay. So the first thing we want to go over, and one of the most basic concepts in programming, is something called a variable. Essentially, a variable is a certain place in a computer that holds data, and it can change what type of data it can hold. Kind of like you have a container and you can fill it with certain things, like you can fill it with different fruits or vegetables, etc. And we call that data types for the things that the space can hold. So some things, examples of types would be integers, doubles, strings, and that kind of thing. So who raise your hand if you know what an int is? Joshua.
It is an integer, a whole number, no decimal.
Exactly. Okay, raise your hand if you know what a double is. Ryan.
It's a number with a decimal point.
Exactly. Raise your hand if you know what a string is. Mr. Patrick.
It's a sequence of characters.
You're so right.
Like text, but also numbers can be strings too.
Yes.
You put them in quotations.
And yes, exactly. One really important thing to notice about what Mr. Patrick just said is that strings are held in quotation marks. So Java has a specific things where it will not be recognized as a string if you do not have it under quotation marks. So it'll run an error if you just have a sequence of characters without quotation marks. And that's an example of syntax, which is something specific to the language of formatting and that kind of thing. There are many other data types, but those are some basic ones and probably the only ones I think we'll be using for this project. Booleans. Oh yes, Booleans. How could I forget? Raise your hand if you know what a Boolean is. Ethan.
True or false?
You're so right. You're so right. So this question, pop quiz, does true or false need to be held in quotations? Exactly. Because if it is in quotations, what would that make it?
A string.
You guys did it. Good job.
Yay.
You guys know variables. Perfect. Okay. And one thing that's important to note is that you guys have to initialize these variables. So you can hold different containers without any like amounts and values in them. So you can just do like right here, you can just do int age, and then you can do the semicolon here. We'll go into that later, but you can end your statement with the semicolon at the end. But you do not need to put the value right away. You can just have the empty storage container, and that'll put a place in the computer memory. But later on, you can add the value later on or right away. Depends on how you want to call it. There's different ways, but we'll get into that later on. You'll see it when we actually do projects, that kind of thing. Does anyone have any questions about that? Or move on? Perfect. Good job, guys.
Thank you. Ooh. Okay. So next thing is methods or functions. So you probably heard of them called functions in your classes before, but methods is just another name for them. So basically, it assigns a functionality to a certain name in memory, and it really helps you organize your code and make sure that you can reuse code so you don't have to type out the exact same thing over and over again. We'll talk about classes later, but generally methods will belong to certain classes, and they're basically certain actions they can call upon certain classes. That's about it. Like you can see, greet is an example of a method. If you call greet, it'll basically just print out hello.
Yes, and we'll go over syntax and how to actually do this stuff later on. These are just kind of concepts. We went over a bit of syntax in the last slide, but we'll go over all that stuff later on. It's just like mostly for concepts. Yes, perfect. Okay, so next we have control structures. Okay, so I don't know exactly how much we'll be doing this in our actual projects, but it's important to know. So essentially, when we're running a program, when the computer reads code that we write, what order does it go into? Does it go from like bottom up, top down? Does it go like left to right, right to left? Just raise your hand. Joshua.
Top down.
Exactly. And does it go left to right or right to left? Exactly. So when the computer kind of. Yes.
The left to right actually depends.
Yes.
If it's an assignment,
Mm-hmm.
kind of right to left.
Yes, but the important thing to notice is it goes top down. So when your computer reads each line, it's going to go from your most recent code all the way down, unless there's specific cases and stuff, but in general, go top down. So there'll be situations when this will change the flow of the computer. Like it might stay on a line for longer and stuff and repeat. So so an example of this might be think of an example. For loops, yeah. Okay. We'll go. So for loop is an example of something that would change the flow of the code. It's an example, like essentially you would write for, I can write it out on the board, but essentially it would be like for condition, then curly braces, and then blah, blah.
Yeah, it'd be a body statement.
Okay. So essentially this is saying that when the computer reads it, it'll like, there's code right here, right? It'll hit this and there'll be it'll read this line. It'll see 4. Okay. It's going to go right here. It's going to read the condition. Who knows what the condition is? Yes.
A thing that is true or false.
Yes. So this will evaluate. So let's say if you're in CSA, you're very familiar with this, but let's say we're painting something, right? We are going to go. Okay. Perfect. Okay. So let's say we want to paint to a certain point on the field, right? So we could check our current location and see, are we at this location? So we can do like for not at location, then that would do blah, 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 blah. So like if we're not at this location, then we can program it to essentially say, we're going to do some action until that's true. And it's going to keep on repeating in that until this condition is either true or false, depending. This is not a good example.
You're more describing a while loop.
While loop, yeah.
But that's okay.
It's all good.
Okay.
Yeah.
Yeah, it's okay, guys.
I think that the key is that a loop repeats something.
Yes.
An if statement can skip around.
Yep.
And what does a switch statement do?
A switch statement.
So a switch case statement is very similar to an if statement. Basically, what it does is it takes in one single variable or expression, it evaluates it, and then based on the evaluation of that statement, it will go through its cases and check each one to see which one matches. So for example, we don't have an example on screen here, but I'll write something actually. We'll see if this is legible. So if we have a switch statement, and for example, so this is very bad. I'll just call it variable. And then above this, we have variable. And variable equals like 4. What we can do is we can go through cases. So for example, case 1, case 2, and then there'll be like body stuff, like blah, blah, blah. There'll be body stuff inside. Case 3, case 4, and then I believe it's called the default.
Can you switch the computer around so Wyatt can see?
And then I believe it's called default. Yep. It's Python's different. Ooh. And there's a default case. So basically what will happen is it'll take this variable, since variable is equal to 4 in this case, it will jump down to where the case is 4, and then it will execute the line of code that's there. And then if there's not a break statement here, it'll actually continue following through until it hits the default case. So that's basically what a switch statement is. It's very similar to an if statement, but it's just structured differently. And it can save you a lot of work if it's in, it can make it so you don't have to write in a huge else if loop, else if conditional if you need to. Yeah. Okay, well, that's the main things that we had today. If we have time, we can continue going.
Did we have slides for my classes?
All right, so at this point, while our presenters are deliberating, are there any questions from anyone so far? Yeah, Josh.
Why do you code in Java and not something like Python?
Ooh, that's a great question. I'm going to throw that to Colin.
Yeah. So first, specifically in FRC, has a designated list of languages that they support out of the box. And for years and years and years and years, there were 3 languages that were supported. Those were C++, Java, and then a language that many of you probably haven't heard of before called LabVIEW. LabVIEW is, take a step back. C++ and Java are relatively similar to each other in terms of syntax. It's text that you write out in an editor, whereas LabVIEW is much more graphical. There's boxes and you draw arrows between them. It's a much more visual style of programming that some people find helpful. I personally don't, and I find it hard to read. So we have never pursued that on this team. Now, last year, there was a 4th language that was officially added in terms of official first support, and let's make this interactive. Who wants to throw out a guess as to what that 4th language was?
Rust.
No, it was not Rust. Zach?
HTML.
No. That's markup language. Sing.
CSS. That's not.
No. All right.
C++.
That's
That's
not a real language.
There's C and there's C++.
Okay.
What's the funniest?
White space.
It is. Yep. Fox. Python.
No.
Yeah.
No, Python first added support for Python last year. And full disclosure, we're kind of thinking about taking a look at it. We just didn't have time this off season. And also, there's some cool stuff that we want to do that we'll take a look at in the auxiliary group later this week. That there's just not support for in Python, at least not yet. So
I want to point out that Wyatt did guess Python. Go Wyatt.
Go Wyatt.
Good job. So Yeah, that's kind of why we're not using any other language. This team specifically, the Sport Dogs here, we did program in C++ for a very, very long time. And then once we started adding more computer science classes at the high school, we switched over to Java because FTC teams can program in Java, so some of them were familiar with that. I think some of the early classes we had at the high school were, no.
We just added Java this year.
But it's more intuitive compared to C++.
Yes. I mentioned C++ and Java are similar in terms of syntax. Only kind of, and you have to do way more work in C++. So if you're just starting out, Java is, in my opinion, an easier language to learn.
I think they call it C minus.
Yeah, two.
No,
All right.
it's because it has just. a
Our
bigger
presenters, are you guys ready to go on to the next thing?
Yes.
Perfect.
Okay. So we are a bit ahead of schedule, which is awesome. So we'll be going a bit into some structural things and more basics. Again, you guys probably already know what these are, but we're just gonna make sure you guys understand this. Okay. So first things first, we're gonna go over what a class is. So I don't understand this example, so Cedric's gonna take this example.
So I put this on there because I wanted to be funny, and I don't know if I'm being funny. But so basically, a class is a blueprint for making an object, which is basically an instant of something. It's basically any single thing can be an object in Java. But a class, if you define one, isn't an actual object yet. It's basically just how you make one and what an object would do. So for a metaphor here, can anyone take a guess at why I put a recipe of spaghetti and a check mark and a spaghetti and a cross? Kirkpatrick.
The class is like the recipe. Just because you have a beautiful recipe for spaghetti does not mean you have a plate of spaghetti in front of you. You must make the spaghetti.
Mm-hmm.
So the class is the recipe, not the plate of spaghetti.
100% correct.
Perfect.
So if you wanted a plate of spaghetti, you'd have to go out of your way to define this is a plate of spaghetti instead of just defining a class.
You would have to follow the instructions
Indeed.
on the recipe.
So that you can construct your plate of spaghetti.
Construct. Okay.
If you're constructing your food, you're
Very
doing
good.
something
Okay.
wrong.
So our next topic is.
I believe subsystems, yeah.
Are we not going over objects? Objects. I'll just explain it verbally. Okay. So something that goes, we don't have a slide for it, but something that goes hand in hand with classes that we just kind of mentioned are objects. So objects are the thing that is actually created from a class, like it would be the spaghetti from the recipe. So an example that we might use for this, just putting it in robot terms, is when you might have like a class for your motors, and then you might have like a specific motor, like this one or this one, etc. So essentially, that's really important because we have lots of different classes for different subsystems and that kind of thing, and then we create the specific objects from them. And we can do tons of different things to these objects. Okay, so this might be a little bit harder question, but there are two components that I'm thinking of that an object has. What two components are they? Keegan. Yes. Okay, you got it. So essentially, every object has behavior and attributes. The behavior essentially is something that an object can do, whereas attributes are things that describe the object. So if we're talking about an object of a house, so we could say Kirkpatrick's house. The attribute could be a color, and it could be black.
It is.
Mm-hmm.
I have a goth house.
And then what's something that an action that the house could do?
Creek.
Yeah.
It does.
So that is one example.
You guys know so much about my house. I could paint it.
Yep.
Which would change the color.
No, it's
And that would change an attribute of the object.
It doesn't have a paint method.
So let's think about this in the robot perspective. So someone give out an object we could have on Obi,
Or
which is
Melman.
Melman,
One of those.
which is right there. Yes.
Like wheel motor.
Yeah, that works, right? Yeah. So what is an attribute we can have, or something that describes it? Think about a motor for the wheels. Yeah. Yes, exactly. I could do the heading, like what direction it's facing. Okay, what's something that it could do? Yeah.
Spin.
Yeah, it could change direction, it could turn on, etc. You guys got it. So that's something kind of like the basics of objects. Anything to add? Good.
Not really. They generally interact a lot with each other,
Mhm.
and it's basically the foundation of Java.
If you guys are a bit confused right now, that's completely okay. It'll make a lot more sense once we actually get our hands on code. So just stick with us. You guys are doing great. Okay.
Want me to take this?
Yeah.
Okay. So now we're going to get into some of the more FRC lingo. So basically, this is our first of two very big slides, but our robot code can basically be described mostly in two big groups: subsystems and commands. And basically, a subsystem is a physical thing on the robot that is meant to do some sort of operation or action. So can anyone give me an example of a subsystem on Melmar? Yes. Keith.
Drive base.
Indeed. We have a drive subsystem. It's one of the more important subsystems, and we will be coding that later. Basically, it just drives around, and it's a very good example. Basically, yes.
So if you think about an object as representing something like a motor or a sensor on the robot, a subsystem is a collection of a bunch of those objects. So you have multiple motors that make up the drive base. There are multiple sensors that are also part of the drive base. All of those individual components need to work together to create that subsystem.
And we generally like to keep our subsystems very separate from each other. So we like to have all of drive be separate from like all of intake, for example, and they're completely different files, and they include completely different motors and everything. And some of the very common methods that we have in subsystems are, for example, the constructor. That helps us basically, it's part of like the recipe that we described earlier. It gives us, tells us what we need to input into a subsystem in order to create it. So for example, for the drive subsystem, does anyone have any ideas for possibly what would be needed in a constructor?
Does everyone know what a constructor is?
Okay.
Okay, let's go over
Do
constructor.
not shake your head. Okay.
Okay, let's go over constructor a little bit.
Yeah.
Do you want to go over everything? Or do you want me to?
I feel like you can explain it in more better terms because you've taken the class.
Colin just raised his hand.
Yeah, I'll take this one. Okay. So we talked about how classes are made up of what we call behaviors and attributes, right? These behaviors and attributes are things that describe and can be performed by or on an instance of the object, right? These are things that we can do with an actual plate of spaghetti or that describe an actual plate of spaghetti, right? The constructor is a special method within the class, within the recipe that says, okay, taking this entire description of how a plate of spaghetti behaves and how you can describe it, the constructor specifically says, here's how you go from this description to the actual object itself. So in order to construct a plate of spaghetti, I need to first say how much pasta is in it, what kind of sauce am I adding on top. You can just change whatever it is you're describing based on how you need to construct it. But the constructor is really the method that is responsible for actually creating or constructing the instance of the object.
That has a lot to do with initialization, as you can see over here, and getting those specific values created.
So in addition to a constructor, there are some other methods that are very common. So for example, specific to FRC, we have a periodic method for some of our subsystems. We mostly just had this because we implemented something called AdvantageKit, which auxiliary we'll cover at a later date. And other than that, we just have very commonly there's like getters and setters, which are basically methods that get and set attributes. So they basically allow us to change the attributes throughout our code throughout a game or other situations.
Very common example of this is like I remember like we use it a lot for like gyro, so we might get like get gyro heading, which is kind of like the direction the gyro is facing. If you don't know what gyro is, it's kind of like we'll go over it more in detail later, but it's kind of like how the robot keeps track of its position and stuff. So we can get throughout the match, we can like periodically get gyro heading and get that information and adjust our code and our robot actions as needed. Because I don't know if we really covered this, but like one really important thing to note is like when you're thinking about coding, when you're thinking about it mechanically, and just like the robot as a whole, there are many things happening at the same time. It is very like, and we'll figure this out once we consolidate at the end. But it's very rare that the robot is just driving. It's just doing this. Like in our matches, Odie was like shooting and firing and moving at the same time. So it's really important to like think about like how we can do all of that without like overlapping and causing errors between each other.
And the other side of the two-part system is commands. Based on the name, does anyone want to take a guess at what commands do? Yeah.
Do they tell the robot to do something?
Generally tell a subsystem.
Tell a subsystem to do something.
So they generally tell a subsystem to perform one specific action, and that action can be, for example, like turn on the intake, or just the intake sequence as a whole. And we generally end up stringing them together into command groups, which we'll cover later. We generally use these for our autonomous modes as well as to map to different joystick buttons on our driver joysticks. And the biggest four methods besides the constructor for a command are initialize, execute, get or end, and then is finished. So the constructor, as mentioned earlier, is basically the special method that helps set everything so that the command can run properly. It generally includes like the subsystem that is being requested, as well as, for example, if we're trying to shoot at a certain degree, the degree that we're trying to shoot at. Initialize is everything that happens when the command is called, like instantly. Execute is ran every single loop iteration of the robot code, which runs every 20 milliseconds for us. And then end is a conditional that gets checked to make sure that end is what happens after the command is ended. And is finished is the boolean that checks basically if our command is finished.
Can we go through an example of what how this could be used in practice?
Sure. So, for example, going back to our concept with like a intake, initialize. When we initialize the command, we generally would turn on the intake. Execute probably wouldn't have anything because we don't need to continue running.
Let's pick an example.
Yeah, it's not all four.
What about setting the angle of the shooter depth on Odie?
Sure. So for initialize, we probably basically set our set points for, this is going to be an unfamiliar term for many of you, but PID controllers. Basically, we're setting our what we want our motors to be at. Execute would just be moving them towards that desired state. End would probably be turning off the any applied power that's left for our motors. And then is finished would basically just be checking whether or not we're at our state.
One important thing to note is that some commands don't use all of these. It depends on just the command you're creating and stuff.
Yep, like the intake examples Cedric was talking about. A lot of times we will, when we're intaking a game piece, when we start the command, we turn on the intake. But once the intake is on, there's not really anything that we need to keep doing, so we won't typically have something in the execute method. There's nothing that we need to execute periodically because we've already done the one thing we need to do. And at that point, we're kind of just waiting for the end of that command. Now, there's a couple things that can trigger the end as a part of this is finished. Either the operator can press a cancel button, or what we like to do in our code is we like to be able to have some way to automatically detect when we've actually picked up our game piece, usually some kind of sensor. And so that sensor can tell us, hey, I see this game piece, you can stop intaking now. So even though we're not doing anything in execute, is finished is continuously checking to see, hey, am I ready to stop intaking? And then the end method is responsible for actually, shutting off the motors and any other end behavior that's needed there.
Good. Okay.
So, as mentioned before, something that's very common is to string all these commands together into a command group. So, like we mentioned before, commands are generally one action of a subsystem. A command group instead, going back to 2 years ago, would, for example, be setting a game piece on a certain position, which would include the action of multiple subsystems. For example, it would include, like 2 years ago, we had our arm on Melman be a subsystem. We had our manipulator be a subsystem. So it would have to string everything together. Do you have something to say?
We should let them guess what they think each of them, like different command groups mean.
Let's do this. Let's think of 2 commands, and let's think about how they're going to behave for each of these different kinds of command groups. So let's say I've got a command that is drive forward. And I've got another command that is, I'm going to simplify here, but let's say that other command is place object. Okay? Go ahead. Take it.
So what does everyone think would happen if we put drive forward and place object in a sequential command group? And what does everyone think would happen if we put it in a parallel?
So first, sequential. So sequential means in order. So, yeah. One second.
Sorry, super quick. I will be acting this out back here.
Yes. So,
Oh,
Zach,
keep
you have to
your
be
eyes
very
on-
descriptive. So, like, think of you like yourself
Alright.
as a computer.
Well,
So, you have to tell Colin bot what to do. So, it's sequential command group, driving forward and placing.
So first, it would start from whatever position it was at. It would move forward, driving forward, and then after it stopped driving forward, only once that command had ended, it would place the object.
Exactly. Perfect.
Yay.
Okay, so let's say now we're going to move on to a parallel command group. So the parallel, that means they're running at the same time. Yeah. Okay, so what do we think would happen? Yes, Joshua.
Colin is going to walk and drop the item at the same time.
Probably running over.
Yeah.
But that's exactly correct.
So that kind of demonstrates there's different kinds of command groups that we use, and we use them depending on what we want to do. But this is very important to like understand and kind of think about because there's multiple things happening at the same time. They're not independent of each other, and you kind of have to think about order and that kind of thing.
An example, a real world, an FRC example of this being important is on Odie, say we have a command that sets our shooter bed to the right angle to fire. And we have another command that is responsible for actually firing the node. If we did a sequential command group, what would happen is the shooter bed would tilt to the right angle, and then once that's done, we'll fire the node and we'll make the shot. If we do a parallel command group, what's going to happen is we're going to fire the note at the same time we start adjusting our angle, and we'll probably miss. We'll either be high or low because our angle is not quite right. So it really is important what kind of command group we choose to use.
By the way, for any virtual people, whenever we say the name Odie, that refers to our 2024 robot, because I don't think we ever explained that.
It's true.
So just for context. And then basically we string all these commands together in a special function that's called add commands. At the end, we sometimes have a add requirements. So this basically prevents us from having to assigning an action to a subsystem like twice at the same time. So we can't, for example, tell the drive base to drive one direction and the other direction at the exact same time. It'll basically just cancel a command if an add requirements command is running it. Do you have anything to add to that?
We have accidentally forgotten to add requirements at various points in the past, and we have accidentally told the robot to drive two different directions at the same time. Does anyone want to take a guess what actually happened?
Motor stall.
No, there was no motor stalling. There wasn't any crying. There was a lot of confusion.
That's fair.
Did you burn a hole in the carpet?
No, the robot kind of just sat there and kind of wiggled a little bit.
Oh wait, yeah, I can imagine why that would happen.
Yeah, so we ran the command. We saw the robot wiggle. We're like, huh, that's weird. What's going on? It's trying to run two commands right now.
Was that at Corn Dog?
Maybe. I don't know. It's happened a couple times.
Yeah.
You know, we should make that a programmable move and put that at the end of the autonomous phase.
Colin says no. Colin
So-
takes up an idea and says no.
Okay, so one
Formatting.
thing that I really love to do and yell at other people about
I
is
get a
their
lot of- I get a lot
formatting.
of-
Okay, so when we share, one important thing to know about code is that it's not just your code. When you're writing, like, unless you're obviously writing it for yourself, but when you're on this team and when you're working on the robot, the code is not going to be just used for you. It's going to be often read and reviewed by other people. And one thing that we really are like want to be intentional about is making sure that everyone can read it. So there's some obvious things about this, like naming variables. You don't want to like make them random letters. You don't want to you want to make them descriptive to the variable and what it's describing.
If you come to me and you say, hey, I've written this piece of code, and even if it works perfectly, if I look at it, you've named your variables A, B, and C, I will not approve that code.
Yes, exactly. Another thing that we as a team have, and a lot of like professional environments have, is like specific formatting and like rules for that. So it'll like come naturally as you guys code, but so you won't have to memorize this. Eventually you will, but so essentially, one thing we do is when we indent in WPI lib and VS Code, I mean not WPI lib. There is an indentation on the bottom right
There's
corner.
a bar.
Yeah, there's a bar, and you can select the indentation that you want. And you can. We always do 4 for that, and we do that for every class.
Yeah, we do that throughout all of our code. It's basically just you click it, it says indent by spaces, and then you click 4.
Yeah. So that's just like spacing and stuff. We also, one thing that you might not be as familiar with, like in CSA, usually, like I know we usually keep the curly braces up here, but one thing that we do is we put the curly braces on this line right here. So rather than keeping it here and opening, we go down to the next line and we keep it open like this. So it's like each curly brace has its own separate line. So that makes it a little bit easier to read. Another thing is that things are aligned, like right here, instead of gyro being right here, you add a couple more spaces just so all of these are lined up, and it's super easy to just go through, read the variable names as you're going down. So there's more things like here that we'll go over, and it'll be a lot easier to see once we're in there, but like we have like commands here are usually at the top and subsystems are at the bottom when you go in your files and stuff. And again, this is just for readability reasons, so that like when you're reading this, it's really easy to comprehend. And when you're reviewing other people's code, because during build season, that's something that we do a lot, it's really easy to understand. Does anyone have any questions about that? I know it's kind of hard to understand unless you see the code in front of you, but
Do we want to bring up the GitHub repo for charge code
we could. I mean,
to kind of show off how we format stuff?
Sure. One thing that I would add to that, one thing that we started doing last year was we started using an auto formatter.
yes.
Which what that means is whenever you build your code, so like you're ready to go and put it on the robot, the whole process of building the code takes a look at all of your code and says, hey, you haven't quite formatted this according to how the team has said we're going to format it. and then it will change the formatting for the whole document. So if you're not using 4 spaces for the indentation, or your curly braces are in the wrong spot, the computer will fix that for you. Now, that's not to say, it's not a free pass for you to get super busy. You should try to adhere to the standards as much as you can. But that auto formatter will act as a guardrail so that you, even if you forgot something, it's still made similar to the rest of our code base.
Do you want to give an example of all of these files and
Yes.
this is what everything looks like?
It's already in.
I love it when they whisper to each other. Secret program leadership secrets.
There's no secrets here, guys. Yes. That help?
Yeah.
Okay, so this is.
the crescendo code or no charge because I think we had to really format really weirdly last year.
It's okay.
Okay, it should be fine.
Okay, so as you can see here, constants, main, and Java are kind of like in their own little place over there. They're in their own little world. Then commands are up here, and subsystems are down here. Actually, you're right, Cedric. I don't want to do this one. Let's go to
So
different
we
one.
had our commands set up really weirdly last year. We generally set them up in a different way. So that's why we were going to go do our 2023 code instead of our 2024 code. They also give us some examples about command groups and other aspects.
Okay, so here we go. There's some weird things in here, but just ignore those. As you can see here, again, constants, main, robot, Java, all these 4. My bad. These 4, they're in their own little world. They're special. So we keep them out of folders because we don't want them in there. So, and then we have our subsystems. They're in here. We'll go into example and we'll show you. Hopefully this one is formatted. I don't know. I worked on this one. It is formatted.
Woo!
Okay. So this is, see all these, this is beautiful. See, it's all lined up. We want that.
I love that.
We don't want it not lined up.
Yeah, because by default it'll have everything offset, so it'll be like zigzagging all over the place.
Yeah.
So that's why we like it all lined up so we can read everything very easily.
Yep. And then I think that's
I
it.
want to show examples of any of the. Does anyone see examples of any of the things we've talked about so far?
Does anyone have any questions? Because if not, we're going to take a short break because you guys have been working so hard and listening so well.
Woo!
Okay, so we're going to take a short break. Feel free to chill out, grab a snack, go to the bathroom, get a drink. We'll reconvene in
There
a little
was
bit.
a thing of Chex Mix packets that expired in late September, so they're still good. We can't sell them though, so they're free game. They're in the kitchen.
There you
They're
go.
free. Wyatt, I'm so sorry I can't get you Chex Mix. I'll throw it across the state of Iowa.
Next time we're gonna go over hardware. We're gonna go over how we're about to make robots. I'm gonna
So, Melvin did not have logging software.
Yeah.
How much of this
It
gets?
did not have advantage.
Okay, my bad. Oh, it doesn't have advantage kit. How much of this gets screwed up by having advantage kit?
So
It shouldn't, because we won't be recreating Melvin's code. We'll be just creating something.
Hey, Eden, right now it's 7:17. What time should I tell Wyatt?
No.
Let's get to
15-minute breaks? Okay. We'll be back at 7:30, Wyatt.
Probably at least go for a
He wants to make.
It's a street then, so I had to make sure it's 0.
thanks, Ethan.
What's your?
And it's not recording.
Okay.